OK, so let's calculate W1, the work for path 1. All right, first thing is I change the volume from V1 to V2. The external pressure is kept constant at P1, so it's minus the integral from 1 V1 to V2 P1 dV. And then the next step here is I'm going from, the pressure is changing. I'm going from V2 to V2 dV. What do you think this integral is? Right, so this is the easy part, right, 0 here. And this one is also pretty easy. That's minus P1 times V2 minus V1. P1 times V2 minus V1. Well, that turns out to be this area right here. Okay, it's V1 minus V2 times P1. This is W1 here. Okay, I can rewrite this as P1 times V1 minus V2 and get rid of this negative sign here. Now, V1 is bigger than V2, so this is positive. Right. So I am compressing. I'm doing work to the system. It's positive work. Everything follows our convention. Number 2 here. Okay, the first thing I do is I change the pressure under constant volume, V1 minus P dV. And then I change the volume from V1 to V2, and then this is P2 dV. This first integral is 0, V1 to V1. Then I get minus P2 times V2 minus V1, or P2 times V1 minus V2. Again, a positive number. I'm doing work to the system to go from the initial state to the final state. But it's not the same as W1. Right? In this case, I have P1 times delta V. In this case here, I have P2 times delta V. Right? And P2 is bigger than P1. W2 is bigger than W1. The amount of work that you're doing on the system depends on the path that you take.